Good morning. We are looking at final exam review. In this case, it will cover from chapters 1 through 5. So we need to be comfortable with a lot of formulas that we have seen, differentiation formulas, logarithmic properties, integration formulas. So we are going to go over what we have seen before. Every example basically is being repeated. We just want to go through them fast and remind everybody of what we have seen. For example, we start with this one. As you recall, we did this, long time ago. The very first step is to rewrite it in such a manner that we can differentiate. So we bring the bottom up, we take it to the power of 1/2, and when we bring it up, becomes negative 1/2. Now, the power rule or the extended power rule can be used. So we can say 4 times negative 1/2, whatever is inside the parentheses to the power of negative 1/2 minus 1, and by the chain rule times 2x. Notice this is the only calculus step, class. The previous step was algebra, and the next step that you are going to finish off, and I'm assuming everybody can do that, this one, both of them are algebra. This is the step that is calculus. We should have no problem. Okay. All right, how about this one? 5 becomes a coefficient. Again, this is the extended power rule or the chain rule. Then the exponent changes to 5 minus 1 or 4. And then we take the derivative of this using the quotient rule. So quickly, the shorthand notation we use for quotient rule is f prime g minus g prime f over g squared. This is shorthand notation. So this piece gives you the top is 2 times the bottom minus 1 times the top over the bottom square. So take a look. 5 sits in front. Okay, class. You use the parentheses with the exponent 4. Then 2 times the bottom minus 1 times the top over the bottom square. This is calculus, and it is done. Calculus and done, everybody. So let's finish it using your algebraic techniques. So what comes at top? First, you need to simplify the top, which is 2x minus 16 minus 2x minus 3, or simply put negative 90. So you're going to simplify that. Then you have a fraction bar where the top is 5 times negative 19 times 2x plus 3 to the power of 4. The denominator is x minus 8 to the power of 4, x minus 8 to the power of 2. So the exponent would be 4 plus 2, or 6 for the bottom. 5 times negative 19 gives us negative 95. Okay. All right. Differentiate implicitly. If need be, you can put a raised dot here to realize this is using the product rule. So 4x squared gives you 8x. Let me just put a raised dot there in case. So 8x times y, and y will give you y prime or dy dx times 4x squared, plus 4y y prime or dy dx, and e. The right side is a number. Any type of a number gives you 0. Doesn't matter. E 10,000 pi 1/3. You're done with your calculus step. Move the 8xy, factor out the y prime, divide, and you're done. So when we do that, moving this one, factor out the y prime, 4 times x squared plus y becomes the denominator of the right side. You simplify, there you have it. The point being, not a lot of calculus step, class. All right. If you recall, I said if you are differentiating sinusoidal functions and we need to use the chain rule, the Easy way out would be the way you read it. So I'm going to read this as y equals cosine. That's all. And I'm going to stop. I'm going to pause. Cosine. So right away, I see the derivative of cosine is negative sine. And I write the same argument, whatever I have here. Then by the chain rule, I need the derivative of this guy, which is 12 t cubed, and I put that in front. So the way you read it, it will help you see the answer. Some basic ones, hopefully everybody remembers. The derivative of tan, okay, is secant squared minus the derivative of secant is secant tan. The derivative of exponential is always itself, so itself. Because the exponent is not x, it's a function of x, by the chain rule, the derivative of that is 5, so times 5. So tan gives you secant squared minus secant gives you minus secant x tan x. And e to the power of 5x, it gives you itself times 5, everybody, times 5. Okay, the distance, the position function, s of t is given. Okay, everybody? And now, s of t is 2t squared minus 5t plus 40, 4 plus 40, where t is time in seconds, and distance is in meters. The average velocity is the good old algebra, okay? Total distance over total time. So if you cover 100 miles over the course of 2 hours, that means 50 miles per hour is your average speed. This is algebra, this is elementary. So we are okay with that. Total distance is s of t sub 2 minus s of t sub 1, and total distance is t sub 2 minus t sub 1. What about instantaneous velocity? Differentiate. And so when we differentiate, we end up with 4t minus 5. We want it after whatever, in this case, 6 seconds. So plug in. And we end up with 19. The units are the same, meters per second. Then the instantaneous velocity is taken care of. The next one is acceleration. Acceleration is the second derivative of the distance function, or the first derivative of the velocity function. In other words, differentiate again. Okay, acceleration is the second derivative of the position function. So a of t is v prime or s double prime. And when you do that, it becomes a constant, class 4. So if it was 6 or 10 or any other time, it wouldn't make any difference. So 4 meters per square second. And the reason the units is meters per square second, because a of t is dv dt. Just to remind you, as far as the units. A of t is v prime, which means dv dt. And finally, the question is, okay, when does the object reach a velocity of 31? Well, you go up here and say this is equal to 31. You solve this elementary equation, and t becomes 9 seconds. Minus 5 goes to the other side, becomes positive 5. Positive 5, okay? So fairly simple class. So, and of course, the reverse process. Given the acceleration, you integrate, you get the velocity function, you integrate again, you get the position or distance function. The equation of a tangent line. So what do we need? Two things. We need a pair. So if you plug in 4 in here, 4 squared is 16, minus 3 times 4, 12 is 4, minus 1 is 3. So that's your pair. What else do you need? You need the slope. How do you find the slope? Differentiate, plug in. Now, please understand this is just a derivative function. What is the slope? When you fix it at a given number, 4. 2 times 4 minus 3 is 5. So now we have the slope. we have the pair. So the point slope, everybody remembers that y minus y1 is m times x minus x sub 1, meaning y minus 3 is 5 times x minus 4. And of course, simplified. By the way, the pair comes from the original function. It also belongs to your tangent line. It should, you can check it also. Related rate problems. When we are dealing in essence with word problem, translation, okay, drawing the setting, all of the above are extremely helpful. So if I'm doing this question, I expect, a drawing. I want to see the setting. So it is extremely important. So even for the exam, you have to draw the setting. So this is what's happening, okay? A 20-foot ladder leans against the building. That's how it looks like. The base slips away. So the base, X represents the base. It's going to go this way. That means Y is going to come down, okay? As it goes this way, it creates the rate of 2 feet per minute for that, okay? So as it slips this way, goes like that, and it's coming down like this, okay? So dx dt, okay, is 2 feet per minute. And we want to see dy dt, we want to find dy dt, okay? And the length of the ladder is fixed at 20 feet. And we want to find that when x is 12 feet, we want to find dy dt. Also notice this is a right triangle, which means a squared plus b squared equals c squared. So x squared plus y squared equals the number that is given as a length 20 squared. Otherwise z squared, okay, if it's missing. So what did we do? We just translated. We are translating class. Okay, now differentiation of this practically finishes the job. 2x dx dt plus 2y dy dt equals, the right side is any number happen to be 400 and it becomes 0. So when you look at this, you're looking to calculate dy dt. So everything is given except dy dt. Also, you can't see y here. So what do? If you plug in x equals 12, you can calculate the y and put it into this. Now, this equation has everything except what we are looking for, namely dy dt. So let's plug in. Okay, 2 times x times dx dt plus 2 times y we just found times dy dt. We can solve this equation. And here's the answer and the proper units. Notice x is increasing, dx dt is positive. Y is decreasing, dy dt is negative, okay? As it should be. All right. We want to find the limit as x approaches infinity. I hope you remember that when that happens, the technique was to divide by highest degree in the denominator. So I want to discuss a couple of things, and then I'm going to go over the indeterminate form and so forth. Basically, when you do limits, you plug in and you observe class. You plug in and you observe, plug in. So what happens when you plug in? When you plug in, you get to a number. You're done. You get to 0 over a number. 0 over a number other than 0 is 0, and you're done. Okay, this is some number class. if you have 0 over 0, infinity over infinity, infinity minus infinity, now you have to work at it. It's indeterminate form. So part A becomes infinity over infinity. The technique was to divide by highest degree term in the denominator, which is x squared, and it gives you the answer 2 over 1 or 2. However, any rational expression, one fast way could be to simplify if you can, and then go to the next step. So I hope you see that you can factor it as follows. X plus 4 drops, and it becomes 2x over x minus 4. So you can work on that if you want. In other words, you want the limit of this one, and you divide by what? You divide by x. If you look at this expression, class, instead of this one, if you look at this expression, what is the highest degree now? X. So you divide by x, the top becomes 2, this becomes 1 minus 4, and it gives you the same answer. And it really doesn't make that much of a difference for a case like that. So take a look at this one now. I hope you realize just the way it is, if you plug in, you get 0 over 0. And so let's use the factored form of that. So factoring will take care of the business. By the way, if you have 0 over 0, it is the 0 in the denominator that creates a problem. So because x is approaching -4, you would expect a factor of x plus 4 in the denominator, and it happened here. See that? I'm telling you that because it will help you with factoring, so you can factor fairly fast. And now when you plug in, you get -8 over -8, which is positive 1. Now, how about this one? Again, this is simple. If you plug in 0, actually, the top becomes 0, the bottom becomes -69, it's 0. Or you can use a factored format and plug in. Either way is fine. And becomes 0. Okay. Again, I want to make a point here. There is a reason, before even I go, there's a reason I went over this. All of these rational expressions, there are basically different ways of approaching it, but the bottom line is factoring is really a good place to start. So if you do this again, the top becomes a number, the bottom becomes 0, but let's look at the factored form class for both cases. For both cases, the top becomes 8 and the bottom becomes 0. Let me just be clear as to what I mean by 8 in the numerator. When x is approaching 4 from the left, the top becomes like 7.9999. If I said 7.9 or 8.1, really doesn't make much of a difference. The top is 8. Why does it make much of a difference? Because both sides of any number has the same sign except 0. So the only number we want to be careful of is 0. So the top is 8 or 7.9 or 8.1. Who cares? But what about the bottom, which is 0? That makes a difference. Why is that? Because any number over 0 results in infinity, but is it negative or is it positive infinity? And that's something you want to be extremely careful. Therefore, if you have any doubts as to what, because you have to justify your answer, then plug in a number to the left of 4, like 3.9, just as an example to show you this thing. If I put like 3.9 minus 4, I get negative 0.1. That means 0 from the left. So why is this important? Now, I know the answer is infinity. I'm looking for its sign. The top is positive. The bottom is negative. Positive over negative gives me negative infinity. If you look at this guy, the same thing. The top is 8. Now, of course, x is approaching 4 from the right, so 8.1 or 8 or 7.9. Again, it's 8.1. But what about the bottom? 0. From the left or right? From the left or right? Well, you should recognizes from the right, but if you have any doubts, pick a number to the right of 4, let's say 4.1 minus 4, and it positive 0.1. Positive 0.1 means 0 from the right, class. And that's really the idea. I hope everybody is clear why we do that. Positive over positive is positive. We are looking for the sign for this guy. We are looking for the sign. So I hope it's clear to everybody, okay? And we can take it from there. All right. Let's look at more examples. What happens here? Just plug in. Plug in and observe 12 over 4 plus 3. E to the power of negative, because there's a negative sign. E to the power of negative infinity means 1 over e to the power of infinity, which means 0. And so the answer is 12 over 4 or 3. So plug in and observe. Okay. E to the power of negative t means e to the power of negative infinity. This one, well, it means 12 over 4 plus 3. E to the power of infinity is infinity, class. And any number, doesn't matter how large it is, over infinity becomes 0. So we just plug it in, we are observing it, becomes fairly simple. Now, I hope you realize this third case becomes like the first case. Take a look. The reason being, because t is approaching negative infinity. So 12 over 4 plus 3 times e to the power of negative infinity, this guy goes to 0. So we get the same result as the first one. So compare the first and the third one and see why they become the same. Okay. Okay. And now just plug in. So 12 over 4 plus 3, e to the power of 0, which is 1. So 12 over 4 plus 3. So plug in and observe, class. Plug in and observe. You see 12 over 7. 12 over 7. Okay. 12 over 7. Let's differentiate. Let's switch gears. The very first step is to rewrite it such that differentiation becomes fairly easy. It is using the extended power rule, okay? So 12 times negative 1, write the parentheses to the power of 1 less. That means minus 1 or minus 2. And by the chain rule, we need the derivative of the parentheses, which is itself 3e to the power of t without the 4. And so rewrite this 12, negative 1, 3e to the power of t, they go to the numerator. This one goes down with a positive 2 in the denominator. Okay. And negative 36 e to the power of t over 4 plus 3 e to the power of t quantity squared. Okay. All of these questions, when we plug in, we end up with 0 over 0. And that's what happens in calculus. Many times we end up with a situation where we need to use our algebraic technique to do something. Okay. And so we want to discuss the algebraic techniques because that's what happens to indeterminate forms. This one, factoring will do the job. And I hope you realize x is approaching 5. So we probably have a, remember the 0 in the denominator is a problem, right? We have a factor of x minus 5 in the denominator. So you factor. You notice there's a factor of x minus 5. You drop it. And now if you replace it, now you get 10 over 5 or 2. 10 over 5 or 2. Okay. Part B, the same thing. You get 0 over 0. So what is the technique? Whenever we have a complex fraction, the technique is to make it into a simple fraction. How? Multiply by LCD, which is 4x. So you multiply the top and the bottom both by 4x, because this is equal to 1, so that is justifiable. So if you multiply this by 1 over 4, you get x. By the second one, you get plus 4. And the denominator, you just write it as a product. So x plus 4 drops. And now you have the limit of 1 over 4x as x approaches negative 4, which is 1 over negative 16, or negative 1 over 16. Okay, class? 0 over 0 again. Technique, multiplication by the conjugate, the top as well as the bottom. And when we do that, we keep the bottom intact, okay, and we multiply the top. So 1 plus h comes out, minus 1 squared, and you write the bottom as a product. So 1 and negative 1 cancel each other. Remember, the 0 in the denominator is a problem, and so h is approaching 0. Now h drops as well, and practically you're done, because if you plug in 0, this becomes 1 and 1, becomes 2, 1/2. And so can we use L'Hopital's rule? Now remember, you couldn't use L'Hopital's rule when we didn't discuss that. Now, because we have, you could discuss the L'Hopital's rule and see whether you can use them or not. All right, logs are involved here, and this is using the product rule. Okay, so let's just quickly put a raised dot here. And we are differentiating. The first one gives us itself, e to the power of 2x times 2, and then times ln x. Ln x gives us 1 over x times the first. Again, this is the only calculus step. And you just have to factor out the e to the power of 2x. It's a simple factor. When the base is not e, you tag along 1 over natural log of that because of the change of base formula. Okay, just remember that the log x, let's say b with base b, is ln x over ln b. So with that being the case, you try to simplify, it can't become simplified, so flip it over, 1 over x squared plus 1 by the logarithmic differentiation, then times 2x by the chain rule, okay, then times 1 over ln of 5 by the change of base formula, okay, and you just rewrite it, following the rule. What if you're doing a part C, and we have also logarithmic differentiation that we have seen? In essence, we are doing the same thing here. We use logarithmic properties to simplify before we move on, which means ln of the top minus ln of the bottom. The top becomes ln2 plus ln x. So ln2 plus ln x minus ln of 2x plus 1. Now, so this was your algebraic techniques using properties of logs. ln2 is a number, 0. ln x, 1 over x, minus ln of 2x plus 1, 1 over 2x plus 1, times 2. You just take a common denominator. So 1 times 2x plus 1 minus 2 times x over x times 2x plus 1. And I don't believe anybody has any problem with that. So it should be fairly obvious. Okay. We have f of x. We want to differentiate. So what is f prime of x? 4 times negative 0.2 e to the power of negative 0.2x minus sine gives you cosine. Of course, 4 times minus 0.2, you're right. That's differentiation. Okay, now let's integrate. How do we integrate 4 divided by negative 0.2? And then e to the power negative 0.2, and then e to the power of negative 0.2x minus sine. The derivative was cosine, but the integral is negative cosine. Negative becomes plus and a constant. And of course, this one is negative 20. I hope everybody knows, simply because it's 40 divided by negative 2. It's the same thing, okay? And just in case, if f of 0 is 20, then you can find an initial value problem, and it should be no problem finding the answer. I hope you recognize, if this is the case, you have 0 and 20, meaning this is capital F of x. Remember that, class? So if you plug in here, you get minus 20 times e to the power of 0 plus cosine 0 and a constant. This is e to the power of 0 is 1 and minus 20 plus cosine 0 is 1 and a constant, and then negative 20 and 1 becomes negative 19. Move it and add it to 20 becomes 39. It's a simple case. So differentiation, integration, initial value problem, all of them are considered in one shot. Okay. When we deal with ln x, that would be a good choice of u when we do substitution. So if you choose u to be ln of x plus 1, then 1 over x plus 1 times dx is du. Okay, class? I hope you recognize that. And of course, this is what? The same thing, right? du. So you're dealing with this, and if you plug in 0, you get ln 1, which is 0. And if you plug in 1, you get ln 2. Okay, so I hope you see what's going on here. You have u du. You plug in 0 into this, you get ln 1. I kept it at ln 1 on purpose. And then you plug in 1, you get ln 2, because then in the next step, I will show you that, of course, ln 1 is 0. So u is 1/2 u squared. And now ln 1 is 0 to ln 2. So you plug in ln 2, becomes 1/2 ln 2 quantity squared, and this one gives you 0. You don't have to worry about that. This is your final answer. So I hope it's clear as to what's going on. Okay, class, very straightforward, I hope. So dealing with a natural log, the choice becomes obvious as to what is the u substitution. If we are differentiating or integrating, makes no difference. The first step is the same. Make up two fractions, class. This is 1. This is another, of course, square root of x is x to the power of 1/2. So going from here to here, it really should be a piece of cake. It happens just in a split second. Now it's the power rule, 1 over 1/2 plus 1, x to the power of 1/2 plus 1, plus 1 over negative 1/2 plus 1, x to the power of negative 1/2 plus 1. 1/2 plus 1 is 3/2. Negative 1/2 plus 1 is 1/2. Let me just quickly write this. So we are going to write 1/2 plus 1 for this. Okay, class. And we are going to write negative 1/2 plus 1 for this. And we are practically done because when we divide by 3/2, that means multiplication by 2/3. Division by 1/2 means multiplication by 2. Okay. All right. Anytime you have a fractional expression, you see if you can simplify, it cannot. Therefore, if you choose u to be the denominator, then du becomes e to the power of t dt. So the integral of du over u, natural log and a constant, replace it. And again, because the expression is positive, you have a choice. You can use parentheses. Dealing with exponentials, normally exponent is a choice of u. So if you do so, then du becomes a 5 x to the power of 4 dx. So we're going to move the x to the power of 4 next to dx. Not that we have to, it just helps see what's going on. So when we do that, number 5 is missing. So notice what we do. So number 5 is missing, okay. We are going to put it there and we're going to undo it by its reciprocal. And now practically we are done, okay. So we write down 1/5 of the integral of e to the power of u becomes 1/5 of e to the power of u and a constant, and we replace it and we are practically done. It's that simple. I hope you realize that, everybody, and know that what you would choose for your u substitution. Okay, so having said that, let's look at this example. And I'm doing this on purpose because I want you to see part A and compare it to that, and you realize that the first step, if I'm differentiating or integrating, is the same. That means when I can divide, I must. So I divide this part. I get 5 over e to the power of negative t, and this part gives me 1. Can't get any easier than that. This one is negative 5 e to the power minus t. This one is t and a constant. And that's it as far as the work is concerned. Okay. Okay. ln x was mentioned. That would be a good choice of u, and therefore du becomes 1 over x dx. Okay, 1 over x dx. So you are dealing with u squared du. That gives you 1/3 u cubed plus a constant, and you replace it. And again, I think I've mentioned that before. I'm going to repeat that because it is important, class. Okay, so this part, do not confuse that with ln of x cubed. Okay, two different things. When you're looking at part B, a fractional expression, the question is, can I simplify it? And if I cannot, then I move on with some sort of a substitution. So if you let the denominator be u, I hope you realize the derivative of the bottom is the top. So the top times dx becomes du. This is by inspection, observation. Inspection, observation. And so we have the following, which is again a natural log and a constant. And replace it. And what's important here for everybody to realize, we can leave it like that, or we can put it in a parenthesis simply because this expression is positive, because as you may remember, the range for e to the power of x as well as e to the power minus x would be positive values of y from 0 to infinity. We want to use differentials to approximate. So let's quickly recap and recall what we had done, class. So when we have a curve like so, this is delta y, change in y along the curve. This is dy, change in y along the tangent line. They are not the same. But many times delta y can be approximated by dy, okay, class? So with that being the case, f of x plus delta x is precisely what you see up here, and it can be approximated by f of x plus dy, and that's what we mean here. So first and foremost, you need a function, okay? So a function, square root of 27, that means we need square root of x, f of x equals square root of x. Then we need a number, the closest number to 27 that we can take the square root is number 25, okay? So we let f of x be square root of x. We want to choose a number close to 27, which the square root is easy to compute, and therefore we find it easy. What is dx? I want to make sure, or delta x, I want to make sure we understand that. Okay, so simply put, it is 27 minus 25. If we wanted to get, let's say, square root of 24, then the x would be 24 minus 25 equals -1. And that's important for everybody to know. So we want f of x plus delta x. We're going to approximate it by that. So differentiation of square root of x, which we have done many times, becomes in order. That's a simple case, 1 over 2 square root of x. dy is the same thing times dx. And so it becomes square root of x plus 1 over 2 square root of x dx. We are interested in finding square root of 27, which means f of 27, okay, which means f of 25 plus 2, which means x is 25 and dx is 2. So plug in. And what happens? 2 and 2 cancel each other. Okay, and you get 5 plus 1 over 5, and you rewrite that. So it's a very simple process, class, okay? But you got to remember how the differentials work, okay? So in short, dy is f prime of x dx. So if anybody asks you, okay, find the differential, first differentiate, and then tag along dx. Okay. How about here? We want to find the absolute max and mean for the following function. Number one, you should know the theorem works only if the function is continuous in that closed interval. This is called closed interval theorem. So that's why when you do the work, if that step is missing, points will be deducted. So you have to first and foremost write down this is a continuous function. Why? It's a polynomial of degree 4. Okay, if it's a polynomial of degree 4, it's continuous where? From negative to positive infinity. So you have to write this. Otherwise, we can't continue because the theorem involves continuity. Okay, all right. Now what do? We want to find critical points. So differentiate and factor. X squared minus 9 becomes x plus 3, x minus 3. So we found f prime. There are two things we want to do. We want to set it equal to 0 and want to see where it doesn't exist. When you set it equal to 0, you get 0, negative 3, and positive 3. Okay, positive 3 is not in between, but you use the other ones. Doesn't exist, it doesn't work. It will always exist because it's a polynomial. So that's the first thing. Okay, so when you set it equal to 0, it creates 3 answers and one of them is out. Now plug in the endpoints, plug in those numbers, and do your observation and writing. Where do you plug them in? Into the original function. Okay, largest number is 0. So this is absolute max. Add 0, 0. Smallest value, negative 81 is the absolute mean. Add this pair. This is your writing. So for the exam, whatever they ask you, you write them accordingly. So when we say absolute max, we are really referring to the y coordinate. So you want to see what they're asking. Okay. Basically, you have a word problem, okay, and you have an optimization problem, and this is a sample of that, okay? There are many, many types of optimization problem we could come across. This is an example of that, class. So the very first thing, a cylinder is inscribed in a cone with a height of h. Then what you need to do, you want to make sure that you do the drawing accordingly, okay, class? And so looks something like that. Now, what do we know? The volume of a cylindrical shape is the area of the base times its height, okay? So if we call this R, we call this H. I hope you recognize that this lowercase r is the radius of the cone, and lowercase h is the height of the cone. Those are fixed values, okay? Now, capital R, so the volume is, pi r squared h, capital H, for the cylindrical shape, where this radius for the cylindrical shape, we call it x, and the height, if this is h, and this distance is y, this becomes capital H, which is h minus 1. So let's write all of those. And let's look at how we can make this volume, which is pi r squared becomes x squared times capital H, which is h minus y, how we can do that and make it a function of one variable, namely x, because there are two variables involved. Number one, if you draw this, class, take a look at this one looks like this. And now similar figures, the corresponding angles are identical, corresponding sides are in ratio. So using that, we can say the ratio of y to x is the ratio of h to r, and we are going to solve for y and replace it here, okay? And we plug in, and now the volume, which was a function of x, now it's a function of x and y, it's just function of x only. It is important to write the limitation on x. In other words, x is between 0 and r, which is a fixed number, classes. R is a number, and that's your interval. Why is that? Because remember, x is the radius of this cylindrical shape. It can, if you bring it down, the height becomes smaller, the radius can get larger and larger, but it will never approach x, because if it does, then it doesn't have any volume. So x is between the two. And now, so we go through the process, v prime of x, and solve and see what happens. We are going to work on it, differentiation, okay? So pi h is fixed, x gives you 2x, so 2 pi h x, minus pi h over r is fixed, x cubed gives you 3x squared. You can write it in this manner, and you can factor it. And now if you set this equal to 0, remember pi and h are fixed. X can be 0 or the parentheses. When x is 0, it's out. When 2 minus 3x over r equal to 0, it gives you 2/3 r. Again, 0 is out. So there are two answers. And as I said, 0 is out. Why is that? Go back and look at the interval that we made up. Therefore, the maximum occurs at 2/3 r if you show this. And that's something that happened with the exam too. A lot of people forgot to justify that. When you find when you find your critical value, it doesn't mean it's going to maximize or minimize. It's just a critical point. What does it do? You don't know. You have to check how, the first or the second derivative test. So you can do the second derivative test. So that means take the derivative again and plug in, and you'll see because it's negative. If it's negative, it means concave down. Negative means concave down. And the maximum occurs then and there, okay? So I'll leave it for you. I think we went over that last time. And so the volume is just plug in, okay? And there you have it. So I'm assuming we are okay with that class. So this is an example that you come across for optimization. Again, not necessarily this one, but remember the process. The process is finding an equation, getting rid of the variables and making it function of one variable, find the critical point, and then prove that we'll maximize or minimize by looking at its second derivative or just first derivative test. And don't forget that you have to come up with the proper interval. We have seen this question. Basically, we are given the growth rate, which is 29 e to the power of minus x. So we are interested in finding how long the fish will be in 4 years, okay? So many fish follow this format, okay? And it starts life with a length of 1 centimeter. So we use what we call the net change theorem, which follows the FTC. Basically, this is if capital L of x is the amount of growth, then L prime or the LDX is the rate of increase. We are going to integrate that from 0 to 4. This integration becomes minus 29 e to the power minus x. From 0 to 4, just plug in. This is the amount. Then we look at the fact that it was 1 centimeter to begin with. We just add the 1. Okay, everybody? We add the 1. And that's the answer. And we go with 1 decimal because they are asking for 1 decimal class. The second method is when we come this far, we can say capital L of x is this one plus a constant, okay? And the initial value L of 0 is 1. If you plug in and evaluate it, you can come up with the C, okay? And what do we want now? L of 4. The advantage of that, but if we want L of anything else, we just plug in. So L of 10, L of 15, so on and so forth. All right. We want to integrate, first thing first, can we simplify, can we factor? The answer is no here if you choose the denominator to be u. The u becomes 4x plus 1 times dx. And it's just a natural log. Replace it, and you're done. You definitely need an absolute value because could be positive, could be negative. However, in part B, we can factor. We must. And that's really the importance of difference between the two. Again, we do the u substitution. The denominator is u. The u is 2 dx. The top is 4 dx. Therefore, we have 2 times 2 dx. It's not a big deal. And we finish the job. The difference, this can be factored. This cannot. We must. Now, to show you how important it is, let's look at the reciprocal of the same guy. And what do? You write the reciprocal of the piece in red. And doesn't require any substitution. You do 2x over 4 and 3 over 4. And this is a simple integration everybody is comfortable with, I hope. Okay. So 1/2 times x gives you 1/2 x squared. That's 1/4 x squared plus 3/4 x and a constant. So the point being, you want to be careful. No need. Doesn't get factored. Yes, there is a need. It does get factored. You must. And this one, no need for substitution. Okay. We're going to use geometry to evaluate. What I want to explain here, if you use any other method when it's asking you for that, it's unacceptable. Okay. So, of course, we don't know how to integrate this in Calc 1. We discussed that in Calc 2, which won't be acceptable for this course. Okay. And so it has to be done by this method. This is y or f of x. And see what it represents. We want to go from -3 to 3. You should show what type of an equation you have and a shape. You must show and prove that this is a semicircle. How do you know that? Because if you square this, you get y squared. And you get 9 minus x squared. And you get a circle centered at 0, 0, which has the equation x squared plus y squared equals r squared. You can't just guess that. You have to show it. You have to prove this is a circle centered at 0, 0 with the radius r. So the area of a circle is pi r squared. We need half of that. Okay. So this is a circle centered at 0, 0 with the radius 3. But what we have is a semicircle. So half of that. I hope you realize why you have to go this route, because we don't have access to calculus 2 yet and techniques that we solve them, and nobody is supposed to use that yet. Okay. All right. So we want to look at this example. And it is simply done by comparing, by inspection. Okay, class? So what do you compare it to? This. The fundamental theorem of calculus, the integral of a to b f of x dx is the limit of this Riemann sum. So compare. It's by inspection, you recognize, and we're going to go from 0 to pi, that's a and b, and you're going to recognize this is f of x of I, change it to f of x, and that becomes x cubed plus x sine x. A is 0, b is pi, there you have it. So how do you come up with the answer? By inspection, class. By inspection, there is no magic here. Just by inspection, compare and figure out what you're given. And vice versa. We may have this one and we want to come up with that one. So going back and forth shouldn't be a problem. Going back and forth shouldn't be a problem. Now, this is the definition. We are going to use the definition to evaluate this, meaning if you calculate this using FTC is unacceptable when it's asking for your definition or use summation, okay? So that means you want to use this one. And in order to do that, you need to figure out what's your A and B. What is your f of x is 1 minus x squared. A is 0, B is 2. And delta x is b minus a over n. So all of the above, you got to get that started. So f of x is 1 minus x squared. A and b 0, 2, right? A and b 0, 2. And delta x is b minus a over n, 2 minus 0 over n. And x sub I is a plus I delta x. All of this is given here. And so you just quickly figure them out. And now plug in and evaluate, okay? Plug in and evaluate. So we have that. Now, what is f of x sub I? Okay, remember, we said x sub I is a plus I delta x. or 0 plus 2i over n or 2i over n. So having said that, 1 minus x squared, right? So 1 minus, plug in this guy, 2i over n, okay, squared, and then delta x. Delta x is 2 over n. So this is by definition, class. So what happens here, you are going to multiply 2 over n by 1, and then this becomes 4i squared times 2 is 8i squared, n squared, and n is n cubed, okay? And so we are going to take the limit of this expression. In order to take a limit, let's rewrite it. We are going to go to the limit toward the n. So we can rewrite this as follows. This is 2 over n times the summation of 1. This is 8 over n cubed times the summation of I squared. Why is that? Because the summation pertains to I and I only. So this is what we have. We want to take this, and summation of 1 is what? Summation of 1 is n. Summation of I squared is what? This piece. Okay. So in essence, you simplify the whole thing, and now you are going to rewrite this as a 2 minus 8n cubed over n cubed plus da 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 da, okay, over 6n cubed. I hope you realize the first term is n cubed in the numerator, okay. N cubed times 2 and times 8, 16n cubed, the bottom is 6n cubed. Again, do you have more terms? Of course, but why is it the first one that we are going to write? Because we are going to take a limit. Because we are taking a limit, we just write the first one, okay, class? 2 is 2. This one is minus 16 over 6, and the rest, they are going down, so each and every one of them goes to 0. Okay, class? So I hope you realize why we did it this way. Again, a quick recap. What is your function, f of x? What is a and b? What is delta x? What is a plus I delta x? You have to write each and every one of them. Okay, class? You have to write each and every one of them. And then evaluate this. You can evaluate this without the limit, and then at the end, take a limit of that. So we are evaluating this is this part. Okay. Fundamental theorem of calculus says if you are differentiating an integral, you get the function back. Okay. If the top is x, you get the function back. If it's not, if it's a function of x, you have to multiply by its derivative by the chain rule. So in this case, we are going to replace the t with x squared plus x, and then because it's a function of x times its derivative, which is 2x plus 1. Okay. I hope everybody understands what happens here. Again, we've been through the proof of that. So take a look at this one. So you use the top and you put it in, so you get t squared becomes sine squared x, and then times the derivative of sine, which is cosine, okay? Minus, plug in tan, minus tan squared, and then the derivative of tan, which is secant squared, okay? Okay, how about this one? We are going to rewrite it with a negative sign and interchanging 1 and sine. Okay, so notice the negative sign. Notice 1 goes down, sine goes up. Okay, the upper limit becomes the lower limit. Sine, the lower limit becomes the upper limit. And now you are going to replace the t with sine, so square root of 1 plus sine squared, and then times the derivative of sine, which is cosine. Don't forget there's a negative in front. and you put the cosine in front. Okay. Newton's method. If you want to use the Newton's method, you have to show certain steps to your readers. Okay, they have to see what you're doing. The process is, what is your function? Okay, what is f prime of x? And then start with a number and show work at least for 1 or 2, and then you can, plug it into a calculator. So the very first thing we are interested in this, 8 root of 500. So what is that? I don't know. X. Okay. If you let this one be x, then x to the power of 8 becomes 500. Take it to the same side, doesn't matter which way. And now x to the power of 8 minus 500 is f of x, f prime is 8x to the power. You have to show all these steps so your reader can see how you arrive at it. And then let's do the writing. X of n plus 1 is this. Now you plug in, and you have to start from somewhere. You can start from like number 2. So you start from somewhere, plug in number 2. So this you have to show, this you have to show, this you have to show, and then you start somewhere. Now plug in that number, and show your reader by hand, okay, you're calculating, and x sub 1 is 2, x sub 2 becomes this number. Show that. Now that you're showing everything, now the next number is tedious. Let the calculator do the job for you, and you come up with the answer. You want it to 8 decimals. Remember that, class. Okay. So you count the number of decimals, and you see what happens. In this one is 2, and the next one is 8. In this one, 2, the next one is 7. This number 7 goes to 8, class. This one, okay, I didn't do a good job. This one, you do the, rounding, gives you the same as this one, okay, with the rounding. And that's important for everybody to follow. The next thing is L'Hopital's rule and how we use that. I want to discuss that because, there have been some misunderstanding as far as the L'Hopital's rule. You cannot use the L'Hopital's rule if you don't show this is 0 over 0 or infinity over infinity. Must write this first. This is a must. If it's 0 over 0, I'm going to use L'Hopital's rule. Okay, so if this is missing, points will be taken off. 1 point, because this is extremely important. You cannot use L'Hopital's rule without this statement. It's equal to 0 over 0 or infinity over infinity, or you name it. So I can't emphasize this enough. L'Hopital's rule cannot be used without this. Okay, now let's use L'Hopital's rule. So the top is 1 over x, the bottom is simply 1. And now if you replace it, you get 1 over x, and that's 1. Okay, so you must show it's 0 over 0. How about the next one? The same thing. You have to show that, or it's unacceptable. If you plug in, you get 0 over 0. Why is that? This is 1. This is minus 1. They cancel each other. This is 0. So the top is 0. And x is 0. So everything is 0. Done. Now, L'Hopital's rule. Okay. E to the power of x minus is plus e to the power of minus x minus 2. This is 1 minus cosine x. Excuse me. Plug in. This is 1 plus 1 minus 2 is 0. 1 minus cosine 0 is 1. So it's 0 over 0. Notice, again, I'm showing you it's 0 over 0. So I can use L'Hopital's rule again. Every step that becomes 0 over 0, you have to show that. And so now differentiate again. This becomes 1. Minus 1 is 0. Sine of 0 is 0. Differentiate again. Okay. So what happens? This becomes 1 plus 1. It's 2. Cosine 1 is 1. 2 over 1. So I hope you see, yes, we did a bunch of steps to get there, but you have to show all your steps. So a quick recap, if you don't have this, you don't have a right to use L'Hopital's rule. Okay. Rolle's theorem. Rolle's theorem says, okay, if we have a continuous in a closed interval, if we have a differentiable function in an open interval, if f of a equals f of b, then we can set f prime of c equals 0 and solve it. That's really the meaning of it. Therefore, you have to show all of that. You can't just go to the last step. Okay, so f of minus 2 equals f of 2. Okay, you plug in and you show that both of them are equal to 8. Rolle's theorem applies. Why is that? We know f is a polynomial of degree 4. Polynomial of degree 4. So it's continuous from negative to positive infinity. Therefore, it's continuous from negative 2 to 2. F is differentiable on negative 2 to 2, and f of minus 2 equals f of 2 equals 8. So you have to show that. Why is it continuous? Okay, you have to write it's continuous in a closed interval. Why is it differentiable? The same thing, it happened to be polynomial of degree 4, so they have the same, reasoning. And so now you can find f prime, set it equal to 0, and solve it. Okay, so f prime is 4x cubed minus 4x equal to 0. So this was a, okay, 4x cubed. And so when you set it equal to 0, you get 3 answers. X is negative 1, 0, and 1. Okay. And so with that being the case, why all 3 are acceptable? Because all 3 numbers are between negative 2 and 2. If you were to graph, it'll look like this class. Okay, if you were to graph, and you weren't asked to graph, okay, but I just wanted to make a point, okay? So there are 3 answers. All right, this uses the mean value theorem. If f prime is between 3 and 5, show that this is the case. Okay, and we are using the mean value theorem. I hope you realize that Rolle's theorem was a special case of a mean value theorem, because the third criterion is not here. The third criterion was f of a equals f of b. If not, f prime becomes f of b minus f of a over b minus a, or you can write it in this way, which really means there is somewhere in between that the tangent line is parallel to the secant line. That's the meaning of it. So first you have to show continuity and differentiability. Because it says f prime is between 3 and 5, that means it's differentiable. So if it is differentiable, it is also continuous. So f is continuous from 2 to 8, and it's differentiable from 2 to 8. Why? Because of this statement class. Okay, so if that is the case, then what do? We start with the mean value theorem applies, and f prime is given that it's between 3 and 5 for all x. So I hope you realize why the mean value theorem applies, okay? Because f prime is between 3 and 5, so it's differentiable and continuous. So f prime is f of b minus f of a over b minus a, or you do the cross product. So this is the case. So if f prime is between 3 and 5, that means f prime of c is between 3 and 5, and f prime of c is this. Okay. So remember, f prime is between 3 and 5. So in this case, f prime for any number. So f prime of any number such as c, which is f of b minus. So we are going to multiply by b minus a, where b and a are 2 and 8. Remember, this is a. and this is b. And so we are going to multiply all sides by 6, okay? And believe it or not, that's the proof. So the Rolle's theorem and the mean value theorem have been discussed here. All right, a particle moves along a line so that its velocity is given. Okay, we want to find the displacement. Okay, we have something called a displacement, okay, which is basically the definite integral of a to b. So the integral of a to b v of t dt is done. Everybody knows how to calculate that. You plug in and you come up with the answer. I'm assuming everybody has an easy time with that. But when it comes to the distance, it's different. What we have covered, okay? And that requires an absolute value, okay? So that means the particle moved 4.5 towards the left. That's the meaning of negative. As far as the distance, we have to use this formula, okay? So that requires figuring out which part is positive, which part is negative. I did that for you. So basically, you end up with this situation, minus v of t from 1 to 3 and v of t from 3 to 4. Why is that? A quick recap, what we did before. This one is equal to t, let's see, plus 2 times t minus 3, okay? So when we want to do the sine graph here, this is sine graph. You know, the sine graph, this is t class, and this is v of t. So this t becomes negative 2 and positive 3, so negative 2 and positive 3. And the only number we are concerned with is 3 because we are evaluating from 1 to 4. Otherwise, so basically to the left, so this is the one that matters, okay? So to the left of 3, you can pick up a number. And evaluate. To the left of 3, maybe even 0 is a good choice, okay, for a test point. If you plug in 0 here, 0 gives you negative, and if you plug in, let's say, number 4 here, okay, 4 gives you, I hope you see that, 4 plus 2, 4 minus 3, positive times positive, okay? And that's how we arrive at this situation. So this is using a sine graph. So you have to show the sine graph to your readers also. And now I'm not worrying about, you know, the integration. You should be able to have no problem. You should be able to do that and have no problem with this integration. So this one is the opposite of this, and this one is identical to that. Just evaluate them. So the opposite of that, from 1 to 3, the same thing from 3 to 4. Do the math. This requires basic math, takes a little bit of a time, no questions about that. And then you add them up, and 61 over 6, which is a precise answer, and about 10.17. And as always, whenever you do math problem, word problems, you want to write them with units if units are given. This one, we discussed the symmetry, if you recall, okay? When a function is an even function, when we go from negative a to a, it's easier to evaluate from 0 to a multiplied by 2. If it's odd, it's simply 0. We go from negative 2 to 2, and we can do the math, you know, it's not a problem. But because it's an even function, we showed that before. It's very simple, class. So f of minus x, so f of minus x is minus x to the power of 6 plus 1, which is x to the power of 6 plus 1, which is f of x. You have to prove that Therefore, we can calculate it in this manner. It makes life easier. And when we do that, we come up with the answer in no time. It's a tad faster. I'm assuming we have no problem with the integration, 1 over 7x to the power of 7 plus x, and then you do the math, okay? So when you have an even function, evaluation from negative a to a is a tad more difficult, okay? Then you go with 2 times 0 to a if it's even, and it's much faster. How about this one? Well, this is an odd function, and it becomes 0, okay? And as I've mentioned before, I want you to work on that. But how do you know this is an odd function, class? Very simple. If you call this f of x, okay, then f of negative x is tan of negative x over 1 plus negative x squared plus negative x to the power of 4. And the numerator becomes minus tan of x, and the denominator becomes 1 plus x squared plus x to the power of 4, which is minus f of x. And that's a proof that this is an odd function. You don't have to do any work. The answer is 0.